I very nearly declined the very kind invitation of Rolf to talk at the symposium because I was concerned that our progress was too half-baked. So I think probably here more as a receiver than I am as a transmitter. But I'm exposing our ideas and thoughts to very much learn from your experiences, and maybe you'll point us in some different directions. So, well, let's begin with a conceptual representation of a city. You know very well that a city is a self-organizing, non-equilibrium, non-linear, open system, which takes in relatively low entropy energy and matter, metabolizes those resources, and exports relatively higher entropy waste products. One thing that I'm very interested in trying to achieve is to evaluate how environmentally sustainable, or rather unsustainable, cities are. I'm keen to try to come up with a measure to identify some kind of unsustainability continuum. Right now, there is no consensus within the scientific literature about how to go about evaluating cities' environmental sustainability. So that's kind of one of the challenges that in our team we've set ourselves. So if we could define some kind of unsustainability continuum, perhaps at the extreme left of that continuum, we'd have what we might call an autarkic state. The problem with that is that really implies that we've got no input of, I can't use my laser, so no input of either renewables or non-renewables, and of course then no export of non-renewables, and clearly we can't sustain life under those circumstances. So the next possibility is that we have an autonomous representation of a city. So now we can import our renewable resources. We don't have non-renewable imports and non-renewable exports. So we can sustain life now, but is that really viable? Perhaps more realistic is that we define a state of regional autonomy, so where the city is working in conjunction with its local regional hinterland for the acquisition of resources to sustain the functioning that we expect of modern cities. The reality is where pretty much every city on the planet lies is somewhere towards the extreme right of that unsustainability continuum. What I don't think we really know very much about at all at the moment is theoretically how far we can push a city towards the left of that continuum, and perhaps more importantly, how we get there. So what sort of strategies could we employ? How would a city be configured if it were to achieve some minimally unsustainable future state? Things get a little bit more complicated still when we try to think about the interactions between environmental and social and economic pillars of sustainability. So even if we could push our city towards the extreme left of that environmental unsustainability continuum, it might be that that's simply economically unviable, or it might be that it's socially undesirable. Perhaps we want to define some socially optimal state for a city. Well, that might mean that we've got pretty much perfect income equality, but then perhaps we lose our economic driver for increases in productivity. So that sort of undermines some people's conception of what might constitute economic sustainability. So my point here is simply that there are conflicts and interactions between these different aspects of sustainability that I think right now are rather ill understood. So as a modeler, and a very naive modeler, I'd like to think that we could define some kind of sustainability volume that would enable us to locate where a city sits if we could somehow come up with an index of social, economic, and environmental sustainability that gives us then some indication of where we need to concentrate our efforts most in improving the state of, or the functioning of the city. and perhaps some underlying fingerprint that would allow us to further isolate where we need to act most urgently. So that very, I suppose, naive thinking is what led to us winning a grant from a charitable foundation charitable trust rather, called the Leverhulme Trust. So in February of last year, we began a 5-year research program to try to understand what city sustainability really means, to try to define it, to try to measure it, and, well, we're all modelers here, so to try to model it. To identify the pathways to transition developed cities, and to accommodate growth in developing cities in near-sustainable ways. I'm a bit of a skeptic, I suppose. I don't believe that we'll ever have sustainable cities, but I'd like to think that we can radically improve upon how sustainable they are. And of course, all of this is for nothing if we don't define the kind of policies and strategies and governance structures that we need to implement these pathways in practice. So for this, we have 4 case study cities. We have 2 in Europe and 2 in China. So in Europe, because it's on our doorstep, then we have Nottingham at the top left. We also have Stuttgart in Germany. It's a similar size. They're both pretty small cities. Stuttgart's partly because we have good connections with research groups there. We have in China Chengdu at the top right and Shanghai at the bottom right. So we have 2 primary cities. That's Nottingham and Shanghai, 2 secondary cities that we're focusing in slightly less detail. The Chinese sort of primary city is Shanghai. These are very different, different spatially, different functionally, different politically, and of course the scales are different by 2 orders of magnitude. Shanghai is roughly 100 Nottinghams. So it's a bit of a challenge. The project is organized into 6 themes. So we've got these kind of vertical themes, the environmental, the social, the economic. We have these cross-cutting themes, modeling, policy, and measurement and data. And my efforts are situated more at the interface between environment and modeling, to some extent also in measurement and data. And, well, in black here, we have the disciplines that are involved. It's a fairly large interdisciplinary research program where we have 9 co-investigators, 8 postdocs now, and we're still recruiting PhDs, but we have 18 slots in total. With respect to modeling, then we have, I suppose, 3 core questions. So one is, if we were charged with planning a new city from scratch, and this is happening in India, or in China, or in South America, how would we go about structuring it? So what would be the optimal configuration of the city, given some target population, given some target distribution of employment sectors? Another question is, how should we manage the evolution of an existing city? So take Nottingham, take Shanghai. Between now and 2050, what sorts of policies and strategies can we put in place to maximize its, or to minimize its unsustainability in the future? And then the other question is, how can we address these challenges for cities of very different functions and scales? So here we're interested in generalizability, but also in parsimony. So I fully concur with Michael Wegener's point that we want our models to be as simple as possible, but no simpler than that. Some general kind of open urban modeling questions, that we're trying to tackle along the way, include, how dense or compact should a city be? And I think we haven't been able to really answer in a convincing way some of these questions, because there haven't been properly integrated models. So how diverse should our cities be? Which transport modes and technologies, which industries, and how tightly coupled should they be? So to what extent can we promote synergetic exchanges of energy and materials between industries and between industry and housing, for example? So we can export heat, for example. How should buildings be designed to reduce resource demands, and of which materials should they be built? To what extent can behavior reduce demands? Which energy conversion, storage, distribution, and control technologies, and so on and so forth. We have a number of seemingly rather simple questions, but to enable us to answer those questions, well, we really do need an integrated urban model. So let's kind of flesh this out a little bit, and it's a little slightly noddy diagram, but I'm just trying to make a point. So we want to generate some population. We want to assign characteristics to the members of that population. That population clearly needs to live somewhere, so we have a demand for land use and infrastructure. Changes in land use have an impact on the urban climate. We've got a change in albedo. Clearly, we're going to be transporting goods and people between our parcels of land, which are, of course, have buildings built upon them. So the transport is also emitting heat. We have anthropogenic heat gains also due to buildings and the activities that are accommodated within them. Our buildings and transport systems are interfaced with an energy system. That energy system can, to some extent, be influenced also by the urban climate. We have industrial processes that are accommodated within buildings, and clearly those industrial processes are also emitting heat. So we have yet more feedback to the urban climate, and of course the urban climate influences the energy demands placed on our buildings. Those buildings also are using raw materials, likewise the industrial processes that are accommodated within them, and so on and so forth. You can see that it's a relatively complicated challenge. So our modeling approach, well, needs to consider different scales. So we want a scalable solution. We have quite often a sort of a disjoint between the existence of data, the availability of data, and the granularity with which that data is available, and we need to bridge gaps. Of course, there are considerable uncertainties in the data that's available to us. We need to come up with strategies for data exchange, etc. And we also need to think about how households and how firms make decisions, and what kind of strategies can bring about change or influence those decisions. So those stimuli include regulatory factors, financial, educational, technological advancements, and social influences, peer pressure. These are things that we'd also like to take into consideration. So, some candidate modeling strategies, and this is where the naivety really kicks in. So we've done some work in the past on modeling the urban climate. These are some results from a simulation program called FVM. This is Basel, so you can't see Basel. This is Basel without Basel. So this is the area of Basel if we take away the city. Okay, so we remove the change in albedo. We've got no urban structure there, and this is what happens. So these are for different time slices, from top left, which is at about 3 a.m., and we're moving in time towards the bottom right, which is at around midnight. And we can see that we've got some considerable difference now between Basel without Basel and Basel with Basel. So with Basel now we're solving for energy momentum transfers between the urban structure and the air. Of course, we also want to take into consideration the dispersion of pollutants, or the emission and dispersion of pollutants. So the tool that we're likely to be using for modeling the urban climate and the future climate, so we also want to take into consideration future climate change scenarios, is WRF, and WRF also has an atmospheric chemistry module which enables us to predict the dispersion of pollutants. Why? Well, because that's rather important. It's estimated that PM 2.5, so small particles, contributed to about 1.6 million deaths in China on an annual basis. That's not trivial. Okay, so we've done some work on trying to model land use. This is a really, really simple model, which has its sort of underpinnings in an Ising model for the physicists amongst you. So we start off, we simply have the representation of 3 different types of land use, and we're trying simply to represent local neighborhood interactions. So lower left here, we've got an original, the distribution of land uses as they are in the Nottingham area right now. We initialize our model by identifying parcels of land. So this is on a 50 by 50 cellular lattice. Parcels of land that are either green or that have a road built on them. So they're pretty much unusable. And then we try to predict land uses. So we iteratively repeat our simulation until we have something that appears to have converged. And here we see that there's a relatively decent agreement between what we predict using this fairly simple model and what we observe. So we're moving off lattice in this fairly naive model. So now we're heading towards the use of zones. These zones are what we call in the UK output areas. So those output areas have a geometry which is fairly consistent in terms of the size of the population that is accommodated from within the boundaries of that output area. Next step is also to optimize our utility function, which defines the transitions in land use. We haven't so far accounted for accessibility, so it's a really naive model. That's something that we're looking at improving. And also to account for combinations of land use that can be accommodated within one of our zones. So right now, they're all or nothing. In the future, we'll look at plot allocations from within one of those zones. We'd like to also predict demographic composition. The social scientists within our team are interested in looking at issues such as social segregation, and some of you have been talking about that today. We'd also like to predict not only the distribution of land and building uses in 2 dimensions, but also to predict growth in the 3rd dimension. So when we're trying to model cities in China, that's particularly important to us. And as part of that, then also to model these larger cities where we have a lack of data describing the 3-dimensional structure, then we're keen to have a basis for synthetically generating the 3-dimensional structure of the city. And one day to handle migration. Okay, I'm not going to talk about MatSim because the experts are here, but that's one of our candidate transport simulation programs. We're also thinking about a standard 4-step zonal modeling approach. For cities that are rather small, like Nottingham, then using a tool like MatSim is quite onerous, but it's feasible. For a city the scale of Shanghai, given the resources that we have available to us within the project, well, then it's probably not feasible for us. So we're probably going to head in the direction of a relatively aggregated model, and in the future towards a model which enables us to, we'll start with a relatively simple cost function and head towards, hopefully, a more sophisticated cost function which uses some knowledge of the topography of the network. Question then, I suppose, is, well, if you're going to go through all that detail, why not use MatSim? So I guess we'll see. Okay, something that I'm more comfortable in is my own creation. There's a tool called CitySim, which is completely inappropriately named. We're not modeling everything in a city. This is just a platform for modeling energy use in buildings and the supply of energy from energy conversion systems that can be integrated into buildings. So of course we can model small neighborhoods, but we can also, with CitySim, model dynamically the demands for heat and power in buildings at the scale of a district, and now we're heading towards the scale of the entire city. So because I know this really well, I'll take a few moments to say a few words about it. So CitySim takes in a description of the scene that we want to simulate in XML file format, generates its own internal description of the scene, and then we perform a set of pre-processes which are basically determining the relationship between every receiving surface from which the envelope of buildings is comprised, and every source of radiant energy. And that could be a sky patch, it could be the sun, and it can be some reflecting building surface. We then calculate a radiation exchange. Once we've performed all of those pre-processes for all surfaces within our scene, we then call a simplified dynamic thermal model, which predicts the energy demands for heating, cooling, ventilating, and lighting within our, and of course for small appliances as well, within our scene. The thermal model and the radiation model provide inputs to a family of stochastic behavioral models. So that can take into consideration people's use of electrical devices, people's use of lights, of blinds, of windows, etc. Then the energy demands of our thermal model are passed to a family of heating, ventilating, and air conditioning models. They may or may not have the, then we call our energy conversion system models, which may or may not have the power to meet the demands of our HVAC models, and if that's the case, then we predict a corrected thermal state within each of the zones of each of our buildings to be simulated. So I'll skip this one. So is it any good? Well, this is a simple comparison of what we predict in CitySim and what we observe for a multifamily apartment building located in a city called Martigny in Switzerland. On x-axis we have on the x-axis we have days. On the y we have the daily total heating energy demand. So in blue we have CitySim, in red we have what was observed, and we can see that generally there's a very close match between these two, except during the summertime period here. So the issue there is that somebody had manually turned off the heating system to that building. So during the periods in which we're predicting a demand for heat, that wasn't being delivered, so of course the temperature decayed within that building. But when the heating system was switched back on again, well, then we recover a pretty close match again. So that gave us some confidence that CitySim is doing a reasonable job. We've used this to model districts, and like I say, we're also using it now to model the city of Nottingham. We've already modeled the city of Nottingham using an alternative strategy, which is based on modeling typologies of building and then extrapolating up from the modeling of those typologies. I won't bore you with the details, but it was a fairly elaborate process. One thing that might be of interest to some of you is that we've developed a tool called Nomass. So that means Nottingham Multi-Agent Stochastic Simulation Program, in which we're generating a synthetic population of agents that can accommodate a building. And then we're modeling the activities that each of those agents performs whilst present. And then dependent upon those activities, we're now predicting their use of windows, lights, shading devices, electrical appliances. We have an appliance allocation model as well. Within this framework, we're also handling social interactions amongst members of the agent population. For processes that, for which data is relatively scarce, then we use something called belief, desire, intent rules. Recently, we've now extended Nomass to be able to enable us to handle agents that represent electrical devices. So they could be supply, storage, or demand devices. using the same kind of architecture. So now we can, in a single computational framework, represent human agents, but also electrical device agents, so that we can explore demand-side management strategies, essentially to enable us to model smart grids and how different devices can communicate with one another to minimize cost or to maximize autonomy, depending upon how we go about structuring our tariffs. So I won't bore you with this, but that's just to say that we're heading in the direction of now modeling CitySim coupled with low voltage networks. We're also developing a solution to model district heating networks. Colleagues in computer science are also wanting to use similar kind of techniques to enable us to model agents' perceptions of environmental sustainability, likewise of social and economic sustainability, and to predict the factors which influence the investments of firms and households. So something that we don't handle in Nomass right now is investment decisions. We only handle operational decisions, and that, of course, is very important when we want to test strategies for that influence the way in which our cities evolve with respect to time. I won't say too much about this, but we're tending towards, well, we've evaluated two strategies for integrating our different modeling tools. One is called the functional mockup interface. The other is a solution called high-level architecture, which has come out of the defense industry in the US. That seems to be promising to us, where we basically create instances of our tools, call them federates. Those federates, we define an object interaction model that defines how our different federates interact with one another. So they publish calls once an event has taken place that other federates can subscribe to. So if there is some change in the scene that we're simulating with one tool, then another tool can choose to call back that change. Another interesting thing with this is that, well, it enables us to handle rather spatiotemporally heterogeneous, I suppose, simulation architectures. So we have different tools which will handle different phenomena at very different timescales. So of course we're interested in modeling changes in land use at annual or perhaps 5-yearly timescales. So now we want to read in a revised scene description in CitySim at the end of an annual simulation, but then during an annual simulation we want to keep that scene constant. Anyway, the high-level architecture enables us to handle this kind of heterogeneity in a rather seamless way. Well, I won't go into this, but the point has already been made that it's important also that we have some spatiotemporal database which enables us to represent the description of a city in a coherent way, but also to be able to track the way in which that city evolves during a simulation. And as with Michael Wegener, then we're also interested in 2050 as our future time horizon. So we are interested in how that scene has evolved and understanding why. So that's it, to wrap up. The planned outcomes, and this is very much a work in progress, is that we have a fairly comprehensive theoretical framework to understand the factors influencing urban sustainability, visions for what constitutes near sustainable cities, a framework for acquiring, managing, and presenting evidence to characterize and model urban sustainability, a modeling framework to test strategies to maximize sustainability, and finally, the types of policies, strategies, and governance structures needed to implement those pathways in practice. Thank you.
Thank you, Darren. And I certainly appreciate that you did come, even though the model is not finished, but that's exactly what we wanted to talk about here. So the floor is open. Any comments?
Thank you. I have two questions, but they're related to one another. I was a bit surprised that you were surprised that in Switzerland the heating systems get switched off April 1st and switched on October 1st. And that comes back to the question that there are general regulations and understandings which we have to include in our models. And that then begs the question, how can we include in our models, particular models which go on for a long time period, the change in regulation? Assume, for example, for the sake of argument, that in 5 years' time, the Norwegian really implement their rule that only electric vehicles can be sold in Norway, or similar initiatives get traction in other countries. So how do we cope with the issue that there is substantial regulatory impact which we might have to look at in our models?
Mm-hmm. Okay. So I guess I was initially surprised about the Swiss rules about heating systems because, well, I was still finding my feet in Switzerland. So when it comes to accommodating plausible regulatory changes, and we can't necessarily know with any real confidence what they are. Well, the solution that we have is a simple one, and that's that we engage with our various stakeholders in our case study cities and try to sort of plot to get a sense of what the future regulatory landscape might look like. And then those can be included in our predictions as exogenous variables. That's the best I think we can come up with at the moment.
Thanks a lot. Thank you very much for the presentation. I pretty much appreciate the holistic approach that you address. And I would like to link my question perhaps rather as a contribution for further debate and also a question to Rolf, basically. Because Michael Wegener already showed that we cannot say this model is a good model or this is a bad model. So the question, you have to select a classical 4-step model or a MATSIM model or whatsoever model. Always depends on the planning task, yeah?
Sure.
And depends on the purpose of the model behind. So that's my point. I mean, we can discuss for days and nights about which model is the best model. That will not really help if we do not know for which purpose we want to develop and then implement it also into the governance decisions. Yeah?
Yes.
So perhaps the question to you, what's the background purpose of this comparative modeling in Nottingham and in Shanghai, and what's the issues behind? And also to Rolf, if you want to set up such an integrated model, what's the idea behind? What's the purpose of the model? What's the expected impact on making use of the model?
Okay, so I'll start and then hand over, shall I, or would you like to? Okay. Okay. So first of all, I couldn't agree more that any good model needs to be fit for a purpose, and well, we need to first of all understand what the purposes are to select an appropriate modeling strategy. So we have some parsimonious model. So that is our starting point. I mean, we've been spending quite a lot of time trying to understand what are the most promising modeling strategies, given what we believe are plausible scenarios that our cities might wish to explore. What we haven't done so far, because we needed to get some way. I mean, we're a relatively large team. There are some members of the team which were new to this kind of domain. So we had a sort of a learning process, if you like, to. In fact, we're still learning, and we'll continue to learn, but we needed to get to a point at which we were sort of ready, if you like, and able to engage with our city stakeholders to then start to understand what are the kinds of scenarios that they would be interested in exploring with us. And it's then that we start to map out, essentially in the next 3 to 6 months, that we map out what our modeling strategies are likely to be, or should be. Yeah. a bit of a slow start.
I can also answer this question for our model. The short answer is I want to use the model to build sustainable, equitable, and livable cities. So that's a short answer, and that may entice a bunch of different scenarios, looking into transit, looking into higher gas prices, looking into zoning regulations, looking into autonomous vehicles. But the longer answer is that this is now a research program that should serve me for the next 30 years to come. And I very much appreciate how Rick was explaining how the demands on the model have changed over time. And so the same I'm hoping to achieve here is to have a flexible model system that can adjust to new questions. And like with Harut, we brought up the question, well, what about people with disabilities? And other times we discuss autonomous vehicles, but I want to have a modeling system where I can address different questions and keep it flexible and keep it agile. So I think for a university research program, it would be too narrow to say, okay, I want to check the impact of tram lines on travel behavior, but I need to have this a little bit broader, a little bit wider.
Yeah, I should have said that the other sort of rationale, if you like, for the choice for case study cities is to test the limits of what can be achieved by our models, or to test the limits of, let's say, the complexity of the challenge that we need to, that we need our models to address, both in terms of scale, but also in terms of the range of different scenarios that we might want to test with our models.
Kai, you had another question? Comment?
Yeah, this is a question I probably have 5 different answers for, and I don't know which one is the correct one. Is what do you need the travel model for?
What do we need the travel model for?
Yeah.
For 2 reasons. Okay, so we want to be able to predict the resource demands of travel. We want to be able to also, okay, so this is a sort of, there's a multifaceted answer, because we also want to determine how our cities ought to be spatially and functionally structured to minimize aggregate resource demands. And that's not a function just of transport, it's a function of other factors, including the 3-dimensional composition of buildings and how they interact with one another, and how they also interact with heating and power networks and so on. So that's a kind of a long-winded way of saying that what we want, well, we need to account for the spatial dependencies of the phenomena that influence resource demands.
Okay, but then I have a follow-up question. This is when we run this stuff, essentially the emissions footprint is proportional to number of kilometers times whatever.
Yep.
Yeah, so I can take a regular car, it's 5 liters per 100 or whatever per 100 kilometers. I don't need any of this congestion stuff. I mean, even for public transit, I can do the same thing. I can say this is a bus, this is a train, this is what it consumes. I assume a load factor. So if I do all of this back of the envelope, I think for resource consumption, I get like 80% of the gains. And if you do 80-20 rule, then maybe back of the envelope would be enough to answer those questions. And you save all this effort on the travel model. You know, I start arguing like Michael Wigner, but...
And that's true, but if we're heading towards a future which is more electric, and in the UK, well, we're heading in the direction of more electric vehicles, more autonomous vehicles. We're also heading in the direction of electrified heating systems, which is, whether that's sensible or not, is contingent upon us having a decarbonized power sector. And so, well, it's interesting to look at now the interactions between buildings, the energy supply systems that are integrated into buildings, the transport, so the vehicles that are connected to buildings that can also act as storage devices. Well, you know this.
Thank you. I'd like to ask a question, probably to multiple speakers, and including Darren, of course, which is to do with the institutional dimensions of these models. Because the models are essentially policy-making tools, it can be research tools as well, so that's one possible answer. While Michael's presentation, actually, this linked the models of multi-hierarchical structure is quite carefully linked to the various spatial and geographical governance structures that we have, because that's the political reality. Many models that we see in the literature and includes this model goes well beyond a particular policy-making institution. Now, that may be fine because you can argue that as researchers we should go beyond it. But on the other hand, these organizations have their own political lives, and these models will need to be used in that political context. I just want to have your thoughts, Darren, first of all, and perhaps also Rolf, in the same conversation that we just had, to have your thoughts, actually, how these models will be used in this institutional context.
Okay, so that's a complicated question for which there isn't a very simple answer. So, the city of Nottingham is, let's say, smaller than the area that most people consider to be Nottingham. So there are a couple of wards that are outside of the municipal boundaries of the city. But people living in those wards believe themselves to be citizens of Nottingham. There are a number of wards outside of Nottingham, and in fact, you know, the larger region where, well, people begin their trips in those more distant zones, and, well, they're working in the city. So it's kind of complicated, and well, it's somewhat artificial, the boundaries that we place around our city. So, or rather, the boundaries of the city are sort of somewhat artificial, considering people's kind of perceptions of where they live. So it's, it's complicated in the sense that, well, to get, we should really include some of these other smaller municipalities in the debate, but then we end up with political toing and froing between these different administrative entities. And that's honestly something that we haven't quite begun yet. We're not the first to try this. They've actually tried themselves to sit around the table and come up with a sensible future planning strategy. And this is a very complicated process. But you're right, it's something that we're going to have to confront in this project.
I can also say a sentence about this. So the reason why I went out of consulting is because I did not want to be in a position where I need to report to one client and do exactly what they want, but rather I can do something that I find scientifically interesting. And applying this model to the Munich region, we only applied here because it's convenient. We know something about this region, but I'm not so much interested in finding the ideal solution, particularly for this region, but much rather into making scientific progress and finding general relationships. So last night over dinner, Michael Wegner was telling me about a scenario that they ran where they quadrupled the headway of buses, if I remember correctly, and they showed that the emissions produced by these additional buses are much bigger than the offset by taking cars from the road. So, and this kind of finding I find fascinating, and this is why I'm into modeling, and not so much because I want to advise a certain municipality in my study area. I mean, if there's an opportunity to work with them, I'd be happy to, but it's further down the road. Yeah, fairly arrogant academic position, but I take this freedom right now.
If I could just add to that, I do think to the extent we might want some of our models to be implemented in informed government policy, I actually think this is a major challenge for land use models because almost any urban region does have multiple municipalities. multiple jurisdictions, and so that institutional, coming back to Rick's notion of a champion, often there isn't a champion or a logical home. Certainly in the Toronto region, where we do not have a land use model, despite my research, is partially because there's a regional transportation agency, there's several agencies concerned about land use, but there's nobody's interested in, well, they claim, but there's nobody responsible for an integrated view, and particularly the land use agencies tend to be non-technical. They're very suspicious of models. I remember years ago, the New York region, the Metropolitan Planning Organization, which they have in the States for New York, was thinking about a land use model, and they could not get any sort of institutional agreement about, the dozens and dozens of municipalities that they wanted a land use model. So I think we see this. Where is the home for this sort of a model in a policy context is a challenge.
I think possibly the one advantage that we have is that we don't have a client as such in the case study cities that we're looking at. They're not paying our costs. So that gives us a certain liberty in terms of what we can explore, and it might be that, and maybe this is very naive, that we can test scenarios that they pose, that also we pose. The model might be a mechanism to help to sort of federate the different institutions, but we'll see.
Just to add to what Rolf said, I think the freedom of being an academic allows you to be a lot more adventurous as well in the things that you could test and propose. I mean, the working in the local area in the northeast of England that we work in is entirely dysfunctional. The land use planning system is insane sometimes, and the local authorities don't talk to each other, the neighbouring local authorities. And so as an academic, you can kind of sit there and objectively say, this doesn't make any sense from a sustainability point of view, and try your best to help out with this process. But I think to assume that everybody's going to listen to what you find is maybe a naive thing that some of us hope that still might happen. But I see in Newcastle has a bit of a strange boundary with the neighbouring local authority, and the neighbouring local authority is building enormous amounts of housing right on the border of Newcastle because they know they don't have to pay for any transport infrastructure because all those people commute into the city and it's someone else's problem. So they just get all of the council tax from the housing, and the transport is the other city's problem. And now to think that neighbouring local authorities would treat each other in such a way is a bit sad, but that's the reality. So I guess, our models maybe don't represent that, but maybe we can at least show them the problems that they might create by doing such a thing and hope to inform the discussion by doing so. Hope, maybe.